Lynette, a prayer? Lynette, can you open, the mic is open. Can you speak to us? Maybe it is network. Can I have someone else lead us in prayer? Someone else?
Sure, I think I can lead.
Okay, thank you.
Let us pray. Heavenly Father, we thank you for the gift of this day. We want to say thank you for everything you have done for us. As we come for this lesson, may you enable us to discuss and understand what the teacher is going to teach. Lord, we know you are the center in our lives and that everything we do according to your will. Enable this lesson to go on successfully so that we are able to achieve the intention of this lesson. I pray all this believing and trusting in our Lord Jesus Christ. Amen.
Amen. Okay. Thank you very much, Lodio, the co-host, the co-teacher. I welcome each one of you to this lesson, and like our prayer, I'll be very glad also when the intention of the lesson is achieved. We are discussing the circle, and last time we talked about the gradient of a circle, from which we could get the equation of the target to the circle and the equation of the normal. I think that is the example that we had last. Today, we are starting off with another example that is to do with where we have 3 points, or where we have a circle passing through 3 points, or where we have 3 points on a circle, and we are interested in the equation of the circle. I will actually read. Can someone read for us? Circle through 3 given points. May I get someone to read what we have there for us? A volunteer, please. Yes, today, can you hear me? Because I just want someone to read for us. Okay, Perpetua, thank you.
Circles through 3 given points. 3 non-collinear points define a circle. That is, there is one and only one circle which can be drawn through 3 non-collinear points. The equation of any circle may be written as x to the power 2 plus y to the power 2 plus 2gx plus 2fy plus c equals 0, where g, f, and c are constants. Thus, if we are given the coordinates of 3 points on the circumference of a circle, we can substitute these values of x and y into the equation of the circle and obtain 3 equations which can be solved simultaneously to find the constants g, f, and c. Example 8. Find the equation of the circle passing through the points 0, 1, 4, 3, and 1, negative 1. Teacher, I'm done.
Sorry, I had not opened my mic. I just continued talking away. I'm very sorry. Thank you, Perpetua. I was actually asking, is Perpetua your name? Or you are using Perpetua's phone or gadget, whatever gadget it is?
Perpetua is my name. I'm called Kato Munji Patrick Perpetua.
Oh, Kato. Kato is a
Yes.
son. Kato is my son. I'm a Salongo.
Hey, nice to meet you.
So glad to be here with Kato.
Yes.
So thank you very much. I said you said it all. When we have a circle through 3 given points, the issue here is that I can get the general equation of a circle. The equation which has been given to us there is the general equation of a circle. But there's a condition there that these must be 3 points that are not in a straight line. If the 3 points are in a straight line, but we can't have 3 points in a straight line if they are on a circle. Maybe if they are somewhere, if they are in a circle. I think we can't have a line going through 3 points on a circle. So they can't be on a straight line. They can't be on a straight line. So if we have these 3 points, so what we do is we simply substitute the coordinates of this equation of this, the coordinates of these points, and we substitute them in the equation of the circle. Allow me to pick this the example here. Then we can then use it and solve for the equation, find the equation of the circle. We can then use it and solve for the equation of the circle. Okay. Okay, as I pick them, we have only said, get this, and after getting this, do what? Get this, and after getting this, you simply substitute in the general equation of a circle. Where do you get the general equation of a circle? You simply will use this general equation. You must be knowing the equation. That's, I think, what I should say. You must know the equation, the general equation. So nobody is going to give it to you. But for now, you can copy it. We have been using it. Some people knew the equation. So for now, you can copy that equation for the circle. This is the question. Find the equation of the circle passing through the points 0, 1, 4, 3, and 1, -1. So copy the general equation for this circle. Now our solution, we are going to pick the general equation of the circle. Is someone ready to give me that general equation for the circle? So in our solution,
Teacher, it is x squared.
So in our solution, the general equation of a circle, Yes, was that Lodio?
Yes.
Give it to me.
It is x squared.
Yes.
Plus y squared. Minus 2ax.
Okay.
Minus 2by. Plus c.
Thank you. So you are using the A, B, and C, and you're saying minus, it doesn't matter. You can go ahead and use -2. I was picking the plus 2gx, but it doesn't matter. I can -2ax minus 2by plus c. And this is equal to 0. Now what happens is that, get the coordinates, substitute in X and Y, each of the coordinates, you are going to come up with 3 equations because these are 3 coordinates 3 points whose coordinates you are satisfying, you are substituting. So when for 0, 1, what does 0, 1 imply? If I use my 0, 1, it will imply that I'm going to have 0 squared, which is 0. My y is 1, so I'll have 1 squared, which is 1. My x is 0, so I'll subtract 0. My y is 1, I'll subtract 2b and add c, and this is equal to 0. And I'll organize it. I'll organize it, collect like terms, put things right, put things properly the way I want them. I want to take my b term over. I want to take my c term over so that I remain with whatever I remain here. So when I take the b term, I'll get 2b. It will become positive on the other side, minus c, and this will be equal to 1. 1 minus 0 plus 0, whatever, they have remained on the other side. So this is my first equation when I substitute 0, 1. Now, may I request that you substitute for 3 and you give me the equation. Please go ahead, substitute for 3 and give me the equation. Oh.
Teacher, the second equation.
You are ready?
Yes.
Sorry, I had my board had an issue. It was small, so I opted for a bigger board and I threw away the other. So you are going to give me, first of all, the first equation. If you still have it, if you don't have it, do you remember the first equation?
Not real.
Okay. When we substituted 0, 1, I'm not going to substitute again. Our first equation was 2b minus c equals to 1. That was our first equation. I hope nobody has issues where we got it from. Can you now give me the second equation?
It is a 4a.
After substituting, you have substituted for 3. So when you substitute for 3, you are getting 4a.
Yes.
Can we substitute together?
Sorry, 16.
This is 16.
Then
what do we have here? 9. Then what do we have here when you substitute x as the 4?
4a.
Not 8. Is it 4?
8, sorry. 8. Then minus, then plus, sorry, minus 6a.
Minus 6b. Good. 6b.
Plus c.
Plus c. And this is equal to
0.
0, isn't it? So yes. Organize it. When
That
you
is
organize it, what
25.
do we get? The 80A can cross over to the other side. So we shall have 8A positive on the other side, 6B positive on the other side.
Minus
Then
C.
the C is negative.
Minus C
And
equals
what is
25.
this equal to?
Negative 25.
Is it negative? When it has crossed it to the other, the negative, the 25 has remained.
25.
It is positive 25 because it has remained on its side. Thank you. Hop, Perpetua, you are moving with us and other people. Can you now substitute the one negative one and give me the result? I'm giving you a minute there. Arnold, are you ready already? Arnold? Arnold, open your mic and take us through.
So, sir, after substituting, you're getting me?
Yes, I get you.
So I got 2 after substituting.
Can you substitute with us? So the first one is
Okay.
1 squared, which is 1.
Then plus negative 1 squared,
Which is?
which is 1.
Good. Now I'm with you.
Then minus, then minus 2a.
Beautiful. I'm moving with you.
Then plus 2b, because the other negative cancels with the other one.
Very good. 2b.
Then plus c.
And this is equal to 0.
So, yeah.
And then when you reorganize, what was the equation?
2a.
Sorry, I am getting you, but let me first get where to write.
Okay.
Okay, the equation is
2a
2a
minus 2b
yes,
minus c
good,
is equal to 2.
equals to 2. Thank you very much. So those are the 3 equations that we come up with when we substitute our points, the coordinates of the points that are given. You will note that after that, Kutosi, I see your message. It's just a greeting. I don't know why you chose to greet. We greeted, but it's okay. I've received it. And it's Kutosi here with us. Anyway, yes, he's here. I was still saying that you are coming up with 3 equations. And after these 3 equations, you notice that you have 3 unknowns. So 3 equations and 3 unknowns match very well. We are going to solve them simultaneously. I wouldn't want younger people to hear that we are also doing simultaneous equations, but we can solve them simultaneously and then obtain the values of A, B, and C. And when we go back to the equation, the general equation of a circle, and substitute those values of A, B, and C, it will give us the equation of the circle. Do you know how to solve 3 equations simultaneously? That's the question now. Arnold, did you still have a question? Or did you still want to comment on something, Arnold? Okay. Can we solve the 3 equations simultaneously? Equation 1, equation 2, equation 3. Yes, Kato, can you do so?
Yes, I can.
What are you going to do?
I will use substitution method. So from equation one, equation one, I can make C my subject of the formula, and I obtain C equals to 2B minus 1. Then I substitute this in the two remaining equations.
Good.
When I substitute in equation 2, I'll get my 8A minus 6B minus, in bracket, 2B minus 1, giving me 25, which will give me 8A. Then minus 80B, giving me 26. And I can call that one, I can reduce, or I can name it, my equation may be 4.
Whenever you have a chance to simplify, to reduce, please go ahead and simplify. However, may I, please, can you check the 26? Is that 26 correct?
Oh, it is 24, sorry. It is 24.
I think.
Yeah, it is 24. Okay, so when you reduce, I'll get my A minus B, giving me 3.
This here is 24. And then you are reducing.
Yes, when I reduce, I get A.
So this will imply that you have 4A. Oh, by what?
No, when I reduce by 8.
By 8. Can you imagine?
Yes.
Makes it quite, yes. Give me what you have.
A minus B equals 3.
Beautiful. Keep that somewhere.
So,
I can call it 4.
Yes. I can substitute for C in equation 3.
So in 3, what will you have?
I'll have A minus 2B minus bracket 2 minus 1 equals 2.
Good.
Which I will have A minus 4B. Yes?
Are you saying A, not 2A?
Not 2A minus 4B,
okay,
giving me
it is
2A minus 4B
minus 4B
equals
giving you
1.
Good.
Yes.
This is our 5. Can we have someone else to add to Kato's work? Yes, Arnold.
So mine is a reaction.
Yours is that?
A reaction.
A reaction.
Yeah.
Please go ahead.
So we form, when we go back to our second equation, but all I'm not mistaken.
Our second equation is which one? Is it that one?
That one of A is A. It's A plus 6B minus C is equal to 25. But then when it comes to substituting in as Kato was doing,
which is somewhere here.
I see him using negative minus 6B, so I'm confused. I don't know.
Come again.
I'm saying when we come to substituting, then we are there where we found C, and then now we are going to use our second equation.
You are somewhere in this here.
Yeah, there.
Mm-hmm.
So our equation was 8A plus 6B.
Plus 6B. And we wrote minus 6B. I am noticing I am noticing that. Yes. And we wrote minus 6B. I never noted that. It is a plus. Kato, are you noticing that? I hope I'm not the one making a mistake. It is a plus. That's what I'm seeing. Okay. Thank you, Arnold.
Yeah.
Can we correct it?
Yes.
We can correct, no problem. So it is 6B minus 2B.
Minus, which is...
So that is going to give us something somewhere here.
4.
This will be minus what?
Minus 4.
4B.
Plus 4. It will be a plus 4.
Plus, thank you. It's a plus 4B. Okay, thank you, Arnold, for that. Noticing that. I didn't see it at all. And can we make the... can we now simplify our equation?
Yes.
Can we now simplify our equation? Somewhere where this is the equation which we can simplify. And when we simplify it, okay, I'm there. Can you simplify? Give me the simpler form. Divide by 4 everywhere, I think.
Yes, 2A.
We shall have 2A.
Plus B.
Plus B.
Giving us 6.
Giving us 6. Thank you, Kato. Yeah, we didn't notice that. I personally never noticed it. And I am glad that someone can follow, because that is the interest of this discussion, that everyone is following. Okay. I think that does not affect our second equation, not so. So equation 5. So we are now working out equation 4 and equation 5 simultaneously. Please go ahead and work them out. And I wanted someone to help come in and give us something after Kato. Arnold.
So now, what we are going to do? Like now we are going to use elimination method.
Okay, we can use elimination method.
You can rearrange them. You can arrange them. Maybe we say 2A minus 4B.
Yes, I'm listening.
2A minus 4B is equal to 1. Then down, we also put the other equation of 2A plus B is equal to 6.
You want to see it nearby.
Yeah.
Okay, this is our 4. This is our equation 4. Okay, go ahead.
And now you can see we already have something we can eliminate it, okay?
Very good.
So we can easily subtract it.
We can
easily subtract.
Sorry about that. My phone was getting, someone called, and the network is getting disturbed when someone calls. I hope I'm there now. I was saying that I think we can subtract 4 minus 5 from 4 to avoid the negatives. What do you think? 4
Yeah,
minus
fine.
5 would avoid the negatives. You know, when you avoid negatives, you get cheaper work.
Okay.
Okay, go ahead and subtract.
Yeah. Then when we subtract, we get B.
We get B.
B being equal to.
How are you subtracting to get B? We
What
are
I'm trying to mean.
subtracting 2A and 2A, which is 0. Then we are subtracting B and negative 4B. I wonder where you are getting the B. Can we subtract B? B minus negative 4B, isn't it?
Yes.
And when we come to this side, it is a 6 minus 1.
Yes.
Okay, go ahead. What do we have here?
Giving us 5B.
5B.
Being equal to 5.
Which is equal to 5.
Yes, finding the value of B as 1.
Finding the value of B as 1. Therefore, our B is 1. Thank you. Our B is 1. Okay, can I have someone give us the value of A now? Someone ready to give us the value? Yes, Caleb. Thank you, Caleb.
We can substitute.
Caleb, I'm listening.
We can substitute in equation 4B in equation 4.
Substituting in 4. Okay, go ahead. What are we going to have?
Which is 2A.
Yes.
2A plus 1.
Plus 1.
Is equal to 6.
Equal to 6.
So we shall have 2A.
So we shall have 2A
is equal to 5.
Good. And what is A?
A is equal to 5 over 2.
And A is 5 out of 2. Very good. Very good. Thank you, Caleb. And can we have the C now? Can we have the C?
Teacher, substitute B equal to 1 in equation 1.
So when I substitute B is equal to 1 in equation 1, what do I come with? Up with?
You get 1.
No, can you substitute in equation 1? And
Yes.
I see what does equation 1 look like? Anyway, we had this other bit that 2C is 2B minus 1. You remember?
Yes.
So what is our C?
Which is,
it is 2 into 1, not so?
Yes.
Minus 1
minus
and gives us our C as 1. Yeah?
Yes.
Okay. Thank you. Now go back to our work. The equation of the circle, and then substitute A, B, and C and give the equation of the circle. Our general equation for the circle, please substitute and give the equation of the circle. I'm waiting. I'm waiting. Go back to the equation of the circle, substitute, and give me the equation. Yes, Kato, are you through?
Yes, teacher, I'm through.
Let's go ahead.
So our equation of the circle will be x to power 2 plus y to power 2 minus 5x
Version of the
minus
circle. Sorry about that. Required equation. Is x squared plus y squared minus 5x. Did you say so?
Yes, minus 5x minus 2y
minus 2y
plus 1
plus 1
equals 0.
equals to 0. Thank you very much. Our equation for our circle is therefore x squared plus y squared etc. Do we have any issues here?
Teacher. Teacher. Teacher.
Any question?
Teacher, I have like an inquiry.
Please go ahead.
Suppose instead of using simultaneous, after me deriving those equations, I just get the values from the calculator.
What method are you using?
Okay, like after deriving all the three equations, I just get the values, the respective values from the calculator.
Yes, I get you. What method will that be? That is my question.
Using the calculator.
Do we have a calculator method?
No.
I would strongly urge you to use the methods that we know of solving simultaneous equations so that you have the values. Because if the question has led us to simultaneous equations, we know how to solve simultaneous equations. There's no need of us thinking that a calculator is stronger. There's no calculator that is stronger than you. You are more powerful. So can you work out the values? Yes, Caleb?
Sir, I was asking if I got equation 2 and equation 3 and I solved them using elimination method, then I eliminate A.
Then you work.
Then I get
you go and solve the resulting equation with the equation 1.
Yeah.
Very, very okay. Now the way of solving simultaneous equations can vary. But that is very, very okay. You can eliminate. Actually, that's what I was thinking personally. Actually, no. Original, I thought about that. I also saw C was very easy to eliminate since everywhere we had minus C. Well, it was also very easy to eliminate.
Okay, sir.
Okay. If there are no other questions, then we can look at the next example. And what is our next example? It is example 9. And what is in example 9? Example 9 is talking about intersecting circles. We actually see that intersecting circles intersect. Circles can intersect with a line. Circles can intersect with one another. But what I would want here to emphasize is that the circles can also touch externally. The circles can touch internally. And the circles they may not intersect, and they may intersect. So there are a number of different cases that can arise. Allow me to share this so that you see. Perpetua, when you are saying you are not seeing, I think you that one was some time ago. You can now see. Okay, allow me to share this a little. Then we see, we read a little about this. The intersecting circle. Okay, can someone read for us something here? But is there much to read? Consider two circles of radius R1 and R2, where R1 is bigger than R2, with their distances, with their centers at a distance d apart. There are a number of possible situations here. In the first situation, we can have that the circles are touching externally. I think each one of us sees what happens if the circles are touching externally. It will mean that the distance between the centers is also the sum of the radii because they are touching. But when they touch internally, that is again something different. That is in the second part here. When they touch internally, and you can still see that the distance of the centers, the distance between the centers is the radius 1 minus radius 2, the big radius minus the small radius. And when circles do not intersect, what happens? You will notice that the distance between the centers is bigger than the sum of the radii. Or the radii, when you subtract the distance, still is less than the difference between the radii. That is when they don't touch externally and also internally. When one is when one is inside another. And then the common condition here is 4, where the circles intersect and they touch. No, they cross at 2 distinct points. In this case, the distance apart is more than the sum of the radii. We have part A here, where you need to note that when circles have the same center, they are said to be concentric. So when we use the word concentric here, then we are talking about circles having the same center. That is concentric. And when two circles, Butera, you are writing on our screen. When two circles are cut at right angles, when two circles cut at right angles, we call them orthogonal. So when we talk about concentric circles, the centers are, the two circles have the same center. And when we talk about orthogonal circles, then the circles touch, or they cut, not touching, they cut at right angles. So those are some of the things that are important that you may need when we look at the next example. Okay, let me pick example 9 here. This is our example 9. Can someone read for us the example? Example 9.
Prove that the circles x squared plus y squared plus 2x minus 8y plus 5 is equal to 0, and x squared plus y squared minus 4x minus 4y plus 7 is equal to 0 are orthogonal.
Prove that they are orthogonal. Allow me to use somewhere where to write. Prove that they are orthogonal. Okay, prove that the circles are orthogonal. We have seen orthogonal means that they cut at right angles. And what did we see if the circles are cutting at right angles? If they are cutting at right angles, it means that one circle here and another circle here the center of this one gives us a radius somewhere there. And also the center of that one will give us a radius somewhere there. Sorry for that. And they are at right angles such that if this is R1 and this is R2, and this is the distance between their centers, R1 squared plus R2 squared is the distance between the circles, the centers of the circles squared. So if you can show this expression here, then you will have proved. So what does this expression require us to get? In the first place, get the radius and also the center of the first circle. Our first circle is x squared plus y squared plus 2x minus 8y plus 5, which I can say equals to -5. I can collect these ones and complete squares. X squared plus 2x. Also y squared minus 8y is -5. Then I complete squares. I'll take half the coefficient and square. I'll also take half the coefficient, which is 4, and square. And I know very well that there is a 1 that I've added 1 squared on the other side. There's also 4 squared on the other side, which I've added, which I also need to add on this side, then subtract 5. So you will notice that I can comfortably say that x plus 1 all squared plus y minus 4 all squared is actually equal to 17 minus 5, which is 4. From this, what is the center of the first circle? The center of this circle, can someone remind us what is the center? Yes, Perpetua.
The center is -1.
-1.
4.
4. And what is the radius for this first circle?
The radius is the root of
The root of 12. Very good. Now I take you back to the second circle, go through the same thing, complete squares, and get the radius for the second circle. I'm giving you a few minutes. Please complete the squares, get the center, and also the radius.
All right, what is happening here? Teacher, there is a hand up.
I thought we would have others, but it's okay. Perpetua, if you are the one now ready, can we go on? For the second equation, our second equation, give it to us. Is
Yes,
x
our
squared,
second
y squared negative 4. Okay, let me write here. So our second equation is x squared plus y squared
Yes.
minus 4x minus 4y. Is it a plus 7?
Yes, it is a plus
Yes.
7.
Okay, take us to what you did.
So I collected like terms.
Go ahead, go ahead.
Yes, I collected like terms and I had x squared minus 4x plus y squared minus 4y giving us negative 7. By completing squares, I obtained x minus 2 into squared plus y minus 2 into squared equals to negative 7 plus negative 2 squared plus negative 2 squared, whereby I obtained x minus 2 into squared plus y minus 2 into squared, giving us 1. From there, I got my center for circle 2 as 2, 2. And my radius 2 as 1.
Thank you very much, Perpetua. Anything that someone would want to say? Arnold, are you comfortable? Arnold was ready to also share with us. Is that okay? Dina, are you just joining? You are, yeah? Yes, Lydia?
I also have the same.
You also have the same. Thank you. And Arnold?
So I also had the same.
You are comfortable. Acham? Acham, have you been with us?
Acham,
Acham, have you been around?
No, I've just joined.
You are bad. You know the time when we are supposed to meet. But okay. As all that is gone, we can continue from there. Okay. Remember the center for the first circle. What was the center for the first circle? Someone who remembers? Center for the first circle?
Yes, the center for the first circle was negative 1, 4.
Negative 1, 4. What was the radius for the first circle?
The radius was The root of 12.
Root of 12. What is our duty now to show that the two circles are orthogonal? In other words, that the circles meet at right angles, they intersect at right angles. Actually, the other way of interpreting intersection at right angles is to be able to say that the radius for the first circle is a tangent for the second, and the radius for the second circle is also a tangent for the first. You can see it on our diagram there. The radius for the first circle is a tangent for the second circle, and the radius for the second circle is a tangent for the first. But how do we how do we show all this? Please go ahead and find the distance between the centers. The distance C1, C2 between the centers. The coordinates of the centers are given. How do we get the distances between the distance between the centers? We subtract the x, which means 2 minus a minus 1, all of it squared, plus, again 2 minus 4, all of it squared, under square root. The whole thing is under the root. Please simplify it so that I get the, simplify it. What does it give to me?
Root of 13.
The root of?
13.
The root of 13. Oh, how did you get that? It is 3. Oh, all right. I was seeing 1. Okay, very good. It's the root of 13. Now, also get R1 squared. Get R1 squared plus R2 squared. What is R1? 1. Okay, R1 is the root of 12. Root of 12, all of it squared. R2 is the 1 squared. And what do you get?
Root of 13.
It is?
13.
Kukunda, what do we get here?
It's root of 13.
Is it root of 13? When I square root of 12 and I square 1 and I add?
It is 13.
13. If R1 squared is that R1 squared plus R2 squared is 13, and the distance between the circles is squared, when we square that distance, C1, C2, is also root of 13 squared, which is 13. If those two are equal, then we shall have proved that the circles are orthogonal. So in your conclusion, I expect you to say that since R1 squared plus R2 squared is D squared, where D is the distance between the centers, then you can say the circles are orthogonal. The circles are orthogonal. The circles are therefore orthogonal. Okay, thank you very much. Do we have any questions on this? Any questions? Is it okay with everyone? Kato, Perpetua?
Yes, master.
Yes, please.
Now, if you go back to our diagram,
would you want me to scroll it back?
Yes, master.
Which diagram? That one?
This one. We can see that D can be obtained by Pythagoras theorem.
Yes.
Now, having known the R2 and the R1, can we use that tactic to find for D? And if we do so, shall we have proved for the circles being orthogonal?
I have missed one small thing. Did you say, if we do so, shall we have?
And we obtain D.
If we do so, shall we have done what?
Shall we have proved the circles being orthogonal?
Thank you. And I want to mention here that no. If you are told to prove, then you don't know. If you don't know that they are orthogonal, you cannot say that Pythagoras gives me this. Pythagoras gives you that if you know. So if the question comes in and says the circles are orthogonal, if the question came and said the circles are orthogonal, then you know. There you can obtain that distance using the radii. But if the question is telling you prove that they are orthogonal, then you don't know. And so you cannot assume that R1 squared plus R2 squared is D squared. However, you can only try and find out if they are equal. If you find out that they are equal, then you have proved that they are orthogonal. Kato, am I answering the question?
Yes, master. Thank you.
Good. Good. Okay. I can then share the next example as we are still continuing. I can share the next example. Example 10. Can someone read for us the example 10? Ukunda, just go ahead and read.
Show that the circles x squared plus y squared minus 2y minus 4 equals 0, and x squared plus y squared minus x plus y minus 12 is equal to 0 intersect in two distinct points and find the equation of the common chord.
Thank you. Show that those circles intersect in two distinct points. Distinct is different. So that they intersect in two different points and find the equation of the common chord. So how do we show that they intersect in two distinct points? How do we show that they intersect in two distinct points? Is my screen on now?
Yes.
Yes.
Okay. So how we show is that we solve simultaneously. And after solving simultaneously, we then show that the resulting equation can, what would I say, can meet the circle at two different points. So get the two equations. One way is subtract them. I can take x squared plus y squared minus 2y minus 4 is 0. Then x squared plus y squared minus x plus y minus 12 is 0. If I took equation 1 and subtracted equation 2, this I would eliminate the x squared would go. The y squared would also go. Then I have 0x somewhere there. It's not there. There's no x. I have 0x and I'm subtracting a negative x. So I have 0 minus a negative x. Then I have minus 2y and I'm subtracting a positive y. And I have minus 4 and I'm subtracting a negative 12. This is equal to 0 when I subtract on the right-hand side. So can we now continue? What is the resulting equation? This gives me an x here.
Minus 3y.
Very good, minus 3y. I can even say it.
Plus 8.
Or plus 8.
Okay.
Plus 8, no problem. Plus 8 equals to 0. Now, that is an equation of a line if you took note. Get that equation and solve it with one of the equations of the circle. Simultaneously with one of the equations of the circle. I'm choosing the first circle. So when I am to solve simultaneously, then it means I can come here and say my x, making it subject, will be 3y minus 8. Then I will substitute in the first equation. When I substitute in the first equation, what do I get? In equation 1, x squared is going to be 3y minus 8.
3y minus 8.
Thank you.
Squared.
Plus?
Y squared.
Plus y squared minus?
2y.
Minus?
4.
Is equal to 0. If you organize this, please go ahead and square the first square. Go ahead and square. What are we going to have when you square?
9y squared.
So we shall have 9y squared.
Minus 48y.
Beautiful. Minus 48y.
Plus 64. Minus y squared. Minus 2y. Minus 4.
Beautiful. Collect like terms. The y squared, when we collect them, what do we get?
10y squared.
10y squared. The 48y and the 2y, both of them are negative.
50y.
Negative 50y. The 64 minus 4.
60.
That is 60. And this is equal to
0.
You can actually reduce, I can see a common 10. Whenever you see those common ones, you remove very fast. Common 10 gives us
y squared minus 5y plus 6
is equal to
0.
Now, if you remember our equations, our product equation, we have what we call the discriminant of the quadratic equation. What is the discriminant of a quadratic equation? The discriminant is b squared minus 4ac. If this discriminant is equal to 0, then it means the roots are repeated. The values of the y in this quadratic equation will be repeated. If the discriminant is negative, less than 0, it means these values are not going to do what? Dina, there are people making noise behind there. Can you mute when you are talking? You can open. If the discriminant is less than 0, that is negative. That means the circles, okay, it means there are no real roots. In our case, it will be meaning that the circles are not what? Are not touching. If b squared minus 4ac is 0, in our case, it will mean the circles are touching. It is a touch. And if b squared minus 4ac is greater than 0, it is positive. That is when it means that we have two distinct points where they meet. I can repeat this. If it is positive, the positive value, the b squared minus, that positive has a perfect root, okay, has a root. And the root is two, there are two values of the root, a plus or a minus. That is the one that is showing the two distinct positions where the two circles intersect. If the b squared is 0, that root is just 0, and so there will be one point where they intersect. That's why we are saying they touch. And if b squared minus 4ac is less than 0, it means they don't touch. So our duty is to find out what is b squared minus 4ac. What is our b in this case? Our b is?
Our b is -5.
Where it? Subtract 4 times a. What is the a?
A is 1.
Times the c. What is our c?
6.
6. So you can work that out and see. It will give us 25 minus
20.
24.
20.
And this gives us a positive value. This gives us a positive value. Because the discriminant is greater than 0, because b squared minus 4ac is greater than 0, it implies that the two circles intersect at the circles intersect at two distinct. The circles intersect at two distinct points. The circles intersect at two distinct points. Now they tell us, but what are those points? Those points are easy to get by solving this. Please go ahead and solve this. What are those points? Solve that one. Arnold, you have something to say?
Sir, I have a question.
Yes, ask.
Like, literally, what do they mean by it? I'm saying.
I can hear you.
I'm saying, what do they mean by distinctive points? I'm kind
Your network is not very good, but what I had
of there.
was you want to find out what they meant by two distinct points. And I said the word distinct simply means different, two different points. And intersecting at two different points is this kind of intersection. I have a circle here. If I had a circle here and another circle somewhere there, those circles intersect at two different points. One point here and another point the other side here. Those circles intersect at two distinct points, there and the other side. So when we talk of intersecting at two distinct points, that's what we are talking about. Because you remember we saw the differences where another circle could be concentric, where another circle could be touching, where another, there were a number of different situations which we looked at before we started working out the example. Okay, Acham has already pushed in her answers. Why is it 2 and why is it 3? I don't know about the others. Now, Acham, when you get y is 2, you haven't got the point yet. Get the x value. You have only got the y value as 2. And you have also got the y value as 3. What are the points? Can you also get the x values so that you have a complete point?
So you bring back the other equation so that we can see it.
Which equation?
The one that had the x, the ones of the cycle.
Lincoln is there. Lincoln is there. Has already produced the values, the coordinates of the points of intersection. Kukunda is there. Beautiful. Beautiful. Where are the rest? Petra is there. Beautiful. Beautiful. Arnold is there. Good. I think we are all getting there. I haven't seen Dr. Lodio. Dr. Lodio Sebo. Mr. Co-host. Assistant teacher.
Yes, teacher.
Yes, what are the values?
I've sent mine also there.
You have sent finally?
Yes.
I hadn't seen. Where is it? Oh, Acham is there, Pepetra is there. Andama Natal. Andama Natal, Lodio yours has not come. Andama Natal is there.
Teacher, I got 1, 3, then -2 and 2.
-2 and 2. I have seen someone who has put them upside down. 2 and a -2. Was that Andama? Andama, you put them upside down. 2 and a -2. It is 2, which is the y. The -2 is the x, I want to think. So it is not 2 -2, but instead it is -2. So you can have here -2, 2, and you can have here, was it 1, 3? Did you say 1, 3? So those are the 2 points where the circles intersect. They are different points as you see them. And that was the question. Show that the circles intersect at 2 distinct points and find the equation. Oh. Sorry. They didn't ask for the point. They didn't ask us for the point. They asked for the equation of the common point, of the common chord. Actually, the common chord is this one here. The common chord is this one here. You don't have to solve. But if you solve the line, the equation of the line is through the 2 points, -2, 2, and 1, 3, it should give you this equation. But you don't have to. The moment you subtract, you get the equation of the common chord. Sorry. I was interested in the points themselves, yet the question did not ask for them. The question asked for the equation of the common chord, and that is x minus 3y plus 8. All x is equal to whichever way you want to give it. This one here, or this one, or that. So that is the equation of the common chord. Have we picked that? Have you noted where we had gone out of range?
Yes, teacher.
We were answering we were looking for the coordinates, yet the question had not asked for the coordinates. I apologize for that. I think I'm the one who guided you to the wrong thing. Yes, Dina?
Sir, pardon on that point of the discriminant. How about when b squared minus 4ac is less than 0? What is the what is the answer?
What is the conclusion?
Yeah.
Dina, I want you to take a note that this discriminant comes from the equation, you call it bulldozer, -b plus or minus the square root of b squared minus 4ac. Now that part b squared minus 4ac is the discriminant all over 2a. So the discriminant comes from the general equation for the quadratic equation. Now, if the value here is positive, if the discriminant here is positive, if we get a positive value, no. If we get a positive value for the discriminant, something here. If I got a positive value for the discriminant, I have a problem here. That part only. If it has a positive value, what does it mean? It means that you are able to get its square root. And when you get its square root, you will add it. And also you will subtract it. And when you add it or subtract it, you will then be able to do what? To get two different values. That's if this was positive. If it is 0, then the whole of this is going to be 0 and you add and subtract is 0. And that is why we said you have one answer. This is the answer. And that one answer is showing you that they are touching. It is only at touch that you will get one answer. And now the question is, what if it is less than 0? Less than 0 means something negative. And if it is negative, the square root of that negative is not real. And so if it is not real, so you will come up with no answers. What is the meaning of coming up with no answers? The meaning is that the circles do not. Either one is there and another there, or one is there and another is inside it. They do not touch. They do not intersect. So that is what it means. The other one was they intersect at two different points. Another was they touch. The touch could be external, or the touch could be internal, an internal touch. That is when we have a 0. The 0 is for touching. The positive is for intersecting at two different points. The negative is for not intersecting. They are not intersecting. Cham, I don't know whether I've dealt with your concern.
Yes, sir. Thank you.
Okay, you're welcome. Perpetua?
Yes, thank you, sir. Sir, another concern would be that is it okay? It's like now a question: is it true that if two circles are intersecting at two distinct points, they are orthogonal?
Oh, circles can intersect at two distinct points when they are orthogonal. They can intersect at two distinct points when they are not orthogonal. So it does not mean that whenever they intersect at two distinct points, they are orthogonal. No, they can intersect at two distinct points, and yet the radii are not perpendicular. The radius of circle 1 is not perpendicular no, the radius of circle 1, yes, is not perpendicular to the radius of circle 2 at the point of intersection. Or one radius does not touch the other circle. So this intersecting at two distinctive points may result into an orthogonal, or it may not result into an orthogonal. So the two possibilities are both there. Okay. I hope, Kato, you are comfortable there, and the rest of us.
Yes, I'm comfortable there, because I thought that now for me I had like if now they are meeting at two distinct points, now that one implies that they are orthogonal.
No. They are orthogonal only when we can prove this. R1 squared and R2 squared added, giving us the distance between the two circles, the two centers. So that's only when they are orthogonal. The rest of the meetings are not orthogonal.
Okay, sir.
Okay. If there are no other cases, Caleb?
Sir, you first, pardon, like when the discriminant is equal to 0.
When the discriminant is equal to 0, it means that they are meeting at one point. You are getting only 1 point. And that 1 point is telling you that there's two circles attaching one another. The two circles either attaching externally, either they touch externally or they touch internally, but they are touching one another. Yes, say what you wanted to say, Caleb.
So that's the only thing I had.
But have I cleared you? Have I answered your query? Okay. I've answered, then that's okay. Okay. We can have, I think we have had a number of examples, but we can have our last for the evening. Example 11 is talking about what? I didn't check that. Oh, my book doesn't have 11. Am I not in trouble? Let me see what 13 has. Let me see if I can get example 11. My book misses a point, and on a page, actually 2 pages. From 300, is that 300? From 393, 93, I think it is, this one is 90 what? From 89 to 93, the number of pages there. It doesn't have 389. Is there anybody with a book wherever they are? Whoop. Let me write this here. Okay, Arnold, you read it for me what you have as example 11. I'm glad. You have a book. Arnold.
I also don't have example 11, by the way.
You have a soft copy of the book.
Yeah, I also don't. I'm not example 11 there.
You are having a soft copy?
Yeah.
Or you have a hard copy of the book? Okay, example 11, I can only type it, find the equation of the tangent to the circle. Find the equation over tangent to the circle. Find the equation. Find the equation of a tangent to the circle. Which circle is this? The circle is x squared So I couldn't see it properly, but I think I have better light now. X squared plus y squared equals to x squared plus y squared equals to 4. At the general point, the general point, what is the point? The point is the point is 2 cos theta. Point is 2 cos theta. Cos theta. Theta, comma. And then 2 sine theta. And the 2 sine theta. And I can see you. Nata, I can see you. Hence, find the equation of the tangent at the point root 2. Hence, find the equation of the tangent at the point root 2. At the point root 2 root 2. Sorry for that. I didn't have that. I didn't notice. and I didn't have it. I hadn't gone through it, but that is, sorry. We could pick it. Could pick it. I think I first make it bigger.
Master, the equation of the circle is not complete.
Wow. The equation of the circle is x squared plus y squared is 4. Is complete. Are you saying that it is not complete?
It had no x squared, it was like plus y squared.
Now I notice what you are saying. I had not noted. X squared. Still made the same mistake the other time. X squared. X squared plus y squared is 4. Okay. Version of. This one should be of the tangent. Okay, I get the point, so thank you. Sorry for that. Excuse me. The thing has refused to pick the copy. I don't know how it copies from here. I refuse to copy. We can work it out from here. I think we can use this. Find the equation. This is example 11. This is our example 11. And work out from here. So we can work from here. This is our example 11. Find the equation of a tangent to the circle, that one, at the general point. Now, when you substitute these general points, you will notice that they go straight there. They must satisfy the equation. So what you are going to do is to use the parameters that you know. X is 2 cos theta. Then you can find out what dx, d theta is. Sorry, my body is upside, is whatever. And also here, y is 2 sine theta. And you also find out dy d theta. So these are the parametric, these ones here. Parametric.
So we are not seeing anything.
I never shared the screen. Kajimu, I'm sorry. I'm sorry. I didn't share the screen. I wrote all that, so should I remove it and rewrite it?
Yes.
But I will write the same things. So in our solution, I was saying, for our solution, these coordinates here are the parametric coordinates. So for your knowledge, because you already know parametric equation, x is 2 cos theta. You again also know that y is also 2 sin theta. So I was saying, go ahead and obtain the x, the theta, and also go ahead and obtain the y, the theta. So those ones, obtain them. After obtaining the y, the theta, obtain the y dx. How do we obtain the y dx? From the y d theta times d theta dx.
Master, I'm done with obtaining the y dx.
Give me the results.
It is negative cot theta.
Start from dx d theta.
Dx d theta, I have negative 2 sin theta.
Beautiful. dy d theta.
I have 2 cos theta.
Beautiful. So what is dy d theta? It is the 2 cos theta times d theta dx, which is negative 1 over 2 sin theta. And this gave you negative what?
Negative cot theta.
Negative cot theta. Beautiful. Very good. Then you can now, that is now the dy dx, which is the gradient. Now, when they tell you find the equation of the tangent, you are getting from 2 cos theta to sin theta, an equation of a line passing through those ones, having a gradient in negative cot theta. So that is the equation of the tangent. The equation of a line with gradient negative cot theta through 2 cos theta to sin theta. So what we are going to do is use an arbitrary point xy. You can use an arbitrary point xy. You can use y is mx plus c. Your way of finding the equation of a straight line. So for me, I am used to using an arbitrary point. So this is y minus 2 sin theta over x minus 2 cos theta, which is equal to negative cot theta. And then you simplify that equation. So how do you simplify? Those are yours. Simplify it, write it in the way that you are comfortable with. Isn't it? Everyone can write in their own language. You can write y minus 2 sine theta is equal to negative x cot theta plus 2 cos times cot plus 2 cos theta cot theta. And that gives you cos squared over sine, whichever way you want to write it. But that is your equation for the tangent. You can actually beautify it. People can write x cot theta plus y minus 2 sine theta minus 2. Don't know how to write this. Cos squared over sine. Should I write over sine as cosec? And this is equal to 0. So that is that's the equation of the tangent. And then after the equation of the tangent, what else would you do? Answer the other question. The other question was saying, find the equation at root 2. Hence tells us to use the result that we have just got. Hence, find the equation of the tangent at the point root 2. How do we use how do we use the result that we have just got? We use it and we get theta. Because we are seeing that 2 cos theta is the root 2. What is theta? 2 cos theta is the root 2. Or 2 sine theta, whichever you choose. 2 cos theta is root 2. So cos theta will be root 2 over 2. Meaning theta is the cos inverse, which is actually 45 degrees. Though here we are supposed to be working in radians to say pi by 40, pi by 4. In radians, I hope each one of us can change things to radians. Can you? And then if that is so, put it in the equation of the tangent. What is the equation of the tangent telling us? Yes, is someone ready? Yes, someone was telling me what is the equation of the line telling us. Are you ready to share with us?
Master, you're still working out. Yeah, just use the calculator. What you have done is substituting in.
So you substitute back there. X cot. So you'll have x cot 45 plus y minus 2 sine 45, which is pi by 4, minus 2 cos squared 45 cosec 45 is equal to 0. So your duty is to find out the sine and the cos, and you be there. Cosine, the tan of 45 is 1. So the
Yes,
cot
yes,
is
yes.
also 1.
Mm.
This is x plus y. The sine is √2/2. The sine is √2/2 minus 2. Cos squared is √2/2 squared, which is a half. Cosec is √2. Sine is √2/2. So cosec is 2/√2. And this is equal to 0. So this will go with that. And we shall have x plus y minus √2. Even this one, 2√2 is going to be √2, which will give us minus √2 is equal to 0. So the equation of that tangent is x plus y minus 2√2 is 0, or x plus y minus 2√2 is 0, or x plus y equals to 2√2. It's up to you, the way you want to give it. You can give x plus y is 2√2. If we choose to give it that way, or someone can choose to give it, sorry. Whichever way you choose to give it. And I'm not doing the very right thing there. But it's up to you. You can choose to give it in your own way. This one here. Okay. I want to stop. But before I wish you a nice evening, may I hear from you? Any question?
Yes, Master.
Yes, please.
There is a question in which Adam and Nato inboxed, and we would wish to have your help there.
I haven't seen it. Where is that? Adam and Nato. Yeah, my chats. I'm not seeing my chats. Okay. My chats are where now. My chat is here. Okay. Find the parametric equations of the circle. Find the parametric equations of the circle. X squared plus y squared minus 4x minus 2y plus 1 is 0. Parametric equations. You have seen the other parametric equations, 2 cos, what was it?
2 cos theta, 2
2
sin
cos
theta.
theta, 2 sin theta. Those are parametric equations of the circle x squared plus y squared is equal to what? To 4. But now this particular one, minus 4y minus 2y plus 1. Can you get the center also?
Yes.
Just go ahead and get the center. And also get the radius. It is the x squared minus 4x plus y squared minus 2y plus 1, which is equal to -1. So you completed the squares, eh?
Yes, I completed the spheres, minus x minus 12 plus
You
y
got what?
minus 4.
So which is equal to 4, isn't it?
Yes.
Okay. So this is equal to 4. So this is a circle. This is a circle whose radius, whose center we can begin with the center. So the center, where is the center?
2, 2, 1.
At 2, 1. And the radius is what?
Is 2.
And the radius is 2. So to obtain the x value, if this is my x somewhere there, if this is my, okay, if I picked on a point somewhere here on the circle, if I'm not doing the right thing. If I picked on a point on my circle, if you pick a point on your circle, point P, which is xy, its x coordinate here is going to be 2 cos theta. When you resolve here 2 cos theta, you get this value here. And that value added to this 2, you get that the x is actually equal to 2 plus 2 cos theta, and the y is equal to 1 plus 2 sin theta. Because to get the x coordinate, you reach it 2 and add this value. This value is 2 cos theta somewhere here. And to get the y value, you will need that and you add that value, and this value is 2 sin theta. So the parametric equations will be 2 plus 2 cos theta for our x. And it will be 1 plus 2 sin theta for our y. 2 plus 2 cos theta for our x and 1 plus for our y. So meaning that if I was to make this subject cos theta, anyway, that is what we wanted to take a note of there, that you can get the x as 2 plus 2 cos and the y as 1 plus 2 sin. Does that answer your issue?
Yes.
So x minus that is cos theta, and the y minus 1 over 2 is sin theta. And from our trigonometry, when I square x minus 2 over 2, I also square y minus 1 over 2, should get 1. That's the equation of the circle. And I think that is what we have. That our equation for the circle is x minus 2 squared plus y minus 1 squared is equal to 4. That's what we have for our circle. So those are the parametric equations for our circle. Yes, there's a hand up by Kukunda. Okay, she lowered it. Kukunda, do you still have something to say?
Yes, teacher, I have. From the previous example, 11.
Go ahead.
Where we have the equation of y.
The equation of
Y.
What equation are you calling the equation of y?
Or I mean that equation.
The equation of the tangent.
Yes. where I have y minus 2 sine theta equaling to minus x cot theta plus 2 cos theta cot theta. So if I decide to make y the subject, and then I obtain 2 sine theta minus x cot theta plus 2 cos theta cot theta. Then I put all the trigonometric expressions in terms of sine and cos. Then I use the point √2 and √2. So I obtain cos theta as √2 out of √2, sine theta as √2 out of √2, and then I substitute in. Is it correct?
I think it is correct.
Okay, thank you.
I think it is correct. When you obtained, what did you get? Didn't you get the right answer?
Yes.
Okay. Okay. Kale, I want to thank you for the evening. Thank you for attending. I know that it is, I can't take you for granted because if you don't come, I will not meet anyone. So thank you for coming. Can we close with a prayer? Can we close with a prayer? Many of our friends have dropped off, I think, because of airtime, data. So we have to thank God for our parents who have given us enough data. Can we close with a prayer? Andam, I can't hear.
Let's pray. Father, I want to thank you very much for all whatever you have done in our lives. For teacher, for what he has done, bless him for more knowledge so that he gives unto us so that we use it appropriately when the right time comes, Father, King of glory. Bless us as we go to different places of our places. Father, Kingdom will be with us. I pray all this believe in trust in the mighty name of Jesus Christ our Lord. Amen.
Amen. Thank you very much. Laudio, I thank you for being there. I know we had our issues when we were starting, but that is no big issue. So I want to wish you a nice evening, and please